You hear a lot about fine-tuning these giant AI models, right? But what happens when you need to build one from the ground up? How do you teach an AI a totally new language? Or, a specialized subject like complex legal jargon? Well, it all starts with one single crucial component. And today, we're going to build it, a custom AI tokenizer. Okay, so let's just dive right in with a question. You've got this state-of-the-art language model, right? It's a genius. But then you feed it a new kind of text. Let's say legal documents or medical research, maybe even just a different language, and it just kind of falls apart. So why is that? How can something so powerful get so easily confused? The answer isn't about intelligence. It's all about its dictionary. And this is exactly what that struggle looks like. On the left, you've got standard English text, totally predictable for a model that was trained on, the internet. But look at the right, a Japanese corpus. The structure, the punctuation, the way spaces are used or not used, it's a completely different world. A tokenizer trained only on English is going to be absolutely lost here.
So you see, the issue isn't that the model is broken. It's a classic case of using the wrong tool for the job. It's like trying to read a new language using an old, completely mismatched dictionary. It's just not going to work.
Yeah, using a pre-trained tokenizer on a completely different language or domain isn't just suboptimal, it's a recipe for terrible performance. It leads to all sorts of inefficiency and just plain bad results. It's kind of like being asked to build a house with nothing but a hammer. I mean, you might make some progress, but it is not going to be pretty.
But here's the good news, right? We are not stuck with that old dictionary. We can actually build a brand new one from the ground up, one that is tailored perfectly to our data. We can train a completely new tokenizer.
Now, what does training a tokenizer even mean? It sounds really complex, but the idea is actually pretty straightforward. It's the process of just letting an algorithm read a huge amount of your specific text, we call that a corpus, and from that, it builds a custom vocabulary and a set of rules. These rules figure out the most efficient way to break your unique text down into these little numerical pieces, or tokens, that a model can actually understand and compute.
And the best part? You don't have to build this thing from absolute scratch. Thankfully, the AI community has already created the perfect tool for this, the Hugging Face Tokenizers library. It's this really powerful yet accessible library designed specifically to build these high-performance custom tokenizers.
All right, so let's pop the hood on this tokenizer toolbox for a second and see what really makes it tick.
Inside the Hugging Face ecosystem, you'll find two main flavors of tokenizers. You've got the slow ones, written in Python, which are awesome for learning and just seeing how things work. But for the real work, the heavy lifting, you're going to want the fast tokenizers. These are written in Rust, which makes them incredibly performant, and they're packed with all the special features you need for pre-training a model.
Now, under the hood, these tokenizers use one of three main subword algorithms you see here: BPE, WordPiece, or Unigram. We are not going to get lost in the weeds on how each one works today, but the important takeaway is that you have a choice of proven, powerful strategies to build your vocabulary.
So how do you actually do it? Well, it really boils down to these four pretty manageable steps. First, you gather your text, your corpus. Second, you pick one of those algorithms we just saw. Third, you feed all of that into the HT Tokenizers library and just let it work its magic. And finally, you save the output. That's it. You've created a custom-built tool ready to go for your model.
So why go through all this trouble? I mean, it sounds like a bit of work, right? Well, because this one technical step is the key that unlocks the ultimate goal of building a totally new AI.
Because once you have that custom tokenizer, you're officially ready to pre-train a language model from scratch. You're moving beyond just tweaking existing models. You're now laying the foundation to build an AI that is a native expert in any domain you choose.
This right here is the real game changer. A custom tokenizer means you can train a model for any domain you can think of. Imagine an AI that wasn't just shown some Python code, but was trained from day one to understand its syntax and structure natively. That's a whole different level of capability.
So I'll leave you with this thought. From ancient legal texts to modern financial reports, from genetic sequences to musical notation, what specialized worlds of text are just sitting there, waiting for the right tokenizer and the right model to finally unlock all the knowledge held within? The tools are now in your hands. Thanks for joining me.